Welcome to the virtual Student Symposium presentation for the 2020 Smart Labs team. We are glad to be able to share with you what we've accomplished over the course of this summer. Our team was composed of undergraduate and graduate students who attend prestigious universities across the country. On the screen, you can also see the different project team roles we played over this summer. The Smart Labs project at LANL is an initiative derived from the University of California's Smart Labs projects and renovations of the university's laboratories. The goal is to incorporate the 7 Smart Labs principles into buildings at LANL so that LANL and DOE facilities are leading examples of high-performing buildings. The 7 Smart Labs components focus on reducing energy expenditure by adding building automation systems, improving ventilation efficiency, and adding LED lighting options. Instead of focusing on one building and adding all these upgrades at that facility, the 2020 Smart Labs team has taken a different approach by breaking down the 7 components and applying one of them at different LANL facilities. This has allowed the project team to identify and solve problems at these specific facilities while implementing new Smart Labs designs. Therefore, we have identified 4 different project areas, each focused on updating lighting, building automation systems, ventilation, and providing sustainability upgrades at specific LANL facilities.
The first project area the team was tasked with was upgrading the lighting in LANL facilities. We created a prioritized list of buildings for upgrades, first focusing on the square footage, as our budget allowed for upgrades of approximately 100,000 square feet of internal spaces. Next, we focused on buildings that were not cleared so that our team would be able to easily communicate with contractors for guidance and estimates. Lastly, we focused on areas with lots of office space so that spaces could be easily upgraded. From our methodology, the team decided to focus our efforts on 2 LANS buildings, TA53 Buildings 1 and 622. Once we selected the facilities for upgrades, the team began to analyze the energy usage of lighting for both structures. For Building 1, we were unable to clearly read the lighting schedule and had to rely on previous energy report cards to find the total energy consumption of the building. We averaged the total usage and calculated between 15 and 20% of the total to get an estimate for the energy consumption of the lighting. For Building 622, we recorded each type of light from the lighting schedule, in addition to the electrical usage for each type, and were able to produce an approximate yearly usage and energy cost. Our team worked with lighting SME Sonia Rodriguez to understand how to go about performing lighting upgrades to the facilities. She explained one of her own lighting projects and got us in contact with the contractor, Amatis. From Amatis, we were provided a detailed lighting upgrade plan and cost estimates. Once our lighting plan is finalized, the team will work to complete a return on investment analysis and look into any other changes that need to be made.
For our 2020 Smart Labs project, our second project area is to upgrade the control system in specific buildings that run on Allerton, which is another type of BAS, into automated logic. With the help of the lab's BAS team, specifically Stuart Rector, we were able to obtain a prioritized list of buildings that currently run on Allerton that the lab would like to switch over to automated logic. From our own due diligence, we have specified 2 buildings for our summer projects, which are technical areas 3-14-15 and technical area 3-14-20. With the help of field engineer and SME of Control Systems, Jeff Fredenberg, we have identified a number of steps necessary for the transition from Allerton to automated logic. First, simple modifications will be made for controller-to-controller swap. This occurs if the power supply for each zone unit already exists and does not need to be updated. Next, new power lines and communications have to be run to each zone unit in the building. Then, large equipment such as HVACs and chillers have to be taken over either through controller-to-controller swap or selecting new compatible devices entirely, which is more costly. Finally, the main system router needs to be updated. This device brings all the controllers in the building and connects them all to each other and to the Ethernet network.
The team was also tasked with sustainably upgrading the nuclear magnetic resonance building in collaboration with Stowe PEs. While the team was unable to be on site, we have had the privilege of still communicating with tenants and received a virtual walkthrough in order to gain more insight into what improvements needed to be made. The biggest issue the tenants have with this building is its trouble cooling. Due to the high energy equipment inside the building, accompanied by poor insulation and HVAC, the NMR building struggles keeping cool. In order to combat this, the team has come up with some innovative solutions, including a green wall that will be implemented on the east side of the building and has an estimated 23% yearly energy savings. The team is collaborating with CHAMP to install a necessary chilled water system, as well as new insulated breakout walls for moving equipment in and out of the building. The current breakout walls are thin sheet metal that amplified the already hot interior, making it uncomfortable for tenants. So the proposed solution is cost-effective and energy-efficient fiberglass breakout walls, similar to those at Oak Ridge National Laboratory.
The last project area is ventilation optimization at TA46-154. This is the physical chemistry lab at LANL. Currently, there are multiple fume hoods which are certified above the industry standard of an 18-inch sash height. It is our team's job to seek creative solutions to reduce the sash height of hoods while keeping negative differential pressure in the laboratory spaces and a phase velocity of 100 feet per minute. Throughout the past 9 weeks, our team has conducted multiple interviews with our ventilation SME, George Urbeck, to truly understand the process of ventilation optimization and how to safely complete this project area. From talking with our project contact, Jenna Waldvogel, we also identified another task within this project area that we can work on. We'll look into switching from Phoenix controls to automated logic, because the controllers are proprietary, so the group cannot access data and change things. The exhaust fans also have a bypass, which means that when the hoods are lowered, the volume air is not changing. It is pulling air from outside to make up that FPM. There are no energy savings for the bypass, so our team is looking at ways to eliminate a bypass in the building. We'll be in contact with our BAS SME, Jeff Friedenberg, to discuss ways to switch from Phoenix controls to automated logic, as well as discuss the possibility of eliminating a bypass in the building. Moving forward, we'll continue talking with our SMEs and we will complete an engineering report of how we will achieve an 18-inch sash height, if it is possible, and what the scope of the work would be, including cost and energy savings.
In this presentation, our team has presented the initial steps, research, and early project designs necessary to carry out these projects across the laboratory in fiscal years 21 and 22. However, our work is not yet complete for the summer. We are still working to calculate thorough life cycle cost analysis and return on investments for each project area so that LANL can further see the benefits of these projects to the facilities listed as well as other facilities across the lab. Finally, the overarching goal of these Smart Labs projects is to provide more stewardship towards upgrading LANL facilities and improving energy efficiency. Without such stewardship through presentations and outreach such as the Student Symposium, further expansion of our Smart Labs components to other areas of the lab becomes much more challenging. To truly be a world-class laboratory and be the example for other laboratories and facilities, LANL needs to continue to support these upgrades so that its facilities, along with its scientists, are also world-class. Our team has confidence that these projects are just the beginning for future work necessary to allow LANL to become a leading proponent of Smart Labs technologies. Finally, we'd like to thank everyone who has helped us over the course of this summer with our project.